Good day, good day. Sorry, I had the wrong thing pulled up. It's the start of the stream, don't worry. I'm just getting reentry put up and everything. Also realized I don't have it going to my Bluetooth, so just 1 second. Okay, there we go. I got it. We're good. Hello, hello, hello. That's right. You know what time it is? It's time to begin the Apollo Shakedown. Alright, missions, Project Apollo. T-minus 4 hours. It's going to be a long one today. I hope you all are strapped in for the long haul. Because, yeah, if you're not, ouch. Because this is going to last at least 2 hours. Yeah? So while this is loading, as always, I'm going to go refill my cup of water because this is mostly going to be a whole lot of me talking and a whole lot of we're not flying today because it's T-minus 4 hours. Yeah. Welcome to Apollo. You all asked for this. All right. You all asked for this. So here it is. Y'all better stay now because this is 4 hours and we're not even gonna fly today. We don't even get the satisfaction of flight. So you all better stay for this at least 2 hours of me explaining shit. All right. Yes. I'm waiting for Madison to join. I don't know. He might be busy. We'll see. He always joins, though. He's like the follower every streamer wants. Dude is hardcore committed to this channel. He has joined every stream at some point. So. Okay. Yeah, a lot of this is going to be done with the flashlight to start out with. I'm sorry. Actually, wait, do we have... No, of course not. It's cold and dark. Why would we have lights? Okay, so... Honestly, well, hello. That's kind of a problem. The checklist is blank for backup crew ingress. But what I suspect it is a whole lot of redacted stuff. Yeah, it just looks like it's a lot of redacted stuff. So we're just going to skip it, and we're going to go right to activation. Or actually, nah, we won't. We won't skip it. We won't skip it. But I'm not going to make any explanations for anything. I'm just going to go right to backup crew ingress then, and... I don't know. This feels weird, actually. I'm gonna revert. I don't know. This just feels wrong. We'll go with activation. We'll have to touch everything at some point or another, so we'll just go right to activation. Or that is not even... Okay, you know what? It is backup crew ingress. Let's do it. Hello? Hello? Yep, so I'm not going to explain this first stuff I'm touching. I'm just going to do it because we'll come around to touching everything at some point. And I'm not entirely confident we're even supposed to be touching this stuff because the checklist is entirely blank. Yeah, so... Oh, why is this? That's not supposed to be like that. That is a typo. That's supposed to be off because we don't even have the circuit breakers plugged in, so... Switch it off. Yeah, we don't have any of the circuit breakers plugged in, but we're not going around plugging in circuit breakers, so interesting. Yeah, I may have to take a look at this a little bit more, but I think maybe some of my checklists may be outdated. Even though it shouldn't be. Alright, circuit breakers, finally. Not for anything that's too important, though. Ah, here we go. Okay. Circuit breakers time. Let me pull up my comments and sort of just run through everything as we go along. Where's Old Man Rebel? Yeah, that's what I want to know. He's really who I'm doing this all for, so I'd be sad if he doesn't watch these, but... Alright, so... Now that we sort of got our switches in the correct position, I'm just going to go through everything in the order that it sort of appears. So there's a lot of stuff, like, we'll touch on later, when we actually test the systems, but then there's a lot of stuff that's just circuit breakers. So I'll explain the stuff that's just circuit breakers, and then we'll talk about the things that we can touch and test prior to launch more in depth. So EPS sensor signal, this is our electrical power system sensor signal. You notice that none of our gauges, none of our amps have anything. We do have a volt readout, which is actually kind of interesting. And also none of our AC or anything. So part of the EPS sensor signal is, well, being able to actually read some of these. And these plug into both the A and B main buses and the AC1, AC2s. CW, that's our caution and warning. We'll talk about this more later. LEM power, we'll talk about more later. Then we have our inverter control. So our inverter control powers up these switches, basically. So those fuses will break the connection to these switches. So it allows us to basically change the inverter configuration. And we'll talk about the inverters a bit later and what they do. But then we have, of course, EPS sensor unit. So here's the signal, and here's the units. We got our DC bus and our AC bus. So again, this is all about like the electrical power, telemetry, and things like that. We do have our voltmeter, but not our ammeter yet. And part of the reason for this, I believe, is because the ammeter may be powered by the AC. Battery relay bus. This powers all of the relays in the spacecraft. So you notice that if we do, what's Reven? For example, fuel cell, yeah, bus ties. You can see, look at that. We can't take these ties on or off, and that's because there's no power to the relay bus. They are self-latching relays, so that means if you were to lose power to the relay bus, these relays are self-latching. There are other relays, though, which are not self-latching that will just open when failed. So, or close when failed, so you do have to be very careful. But you can see when we do put one on, if we were to connect up the batteries and go full internal, we would most assuredly get the readouts for these talkbacks. Once their circuit breakers are in, though, they're probably not in yet. So I'll show you what happens when you unplug the relay bus after we have full power up. But that's basically what it does. It controls the spacecraft relays. Relays are in bus ties, they're in certain switches, they're also in the sequential event control system, the logic switches. These are all relays. Now, a redundant set of relays, but they're all relays nonetheless. So if you pull the battery relay bus, it is possible that if those pyros are reliant on the battery relay bus, you can't do it. We can double check if they are, and we can see, yep, battery A, battery B, direct power. So most likely this goes to the relay bus at some point. Just something to keep in mind. We've got our environmental control system radiators, the controller for that, which is powered by AC. That allows us to use these switches here to control our radiators. And then, of course, we have the control heaters and the overload heaters. So overload heaters is like when it gets too cold, you have the high power heaters, and then the control heaters are, again, part of it is control, but with the main tie instead of the AC tie. And the controls are related to the heater system, and so the heater controls go through the main bus, and then the actual radiator controls go through the AC. So that's kind of what that means. And then we have our overload heaters on our batteries. Coming through, we've got the battery charger. These two circuit breakers here, they supply the bus power for the battery charging on A or B. And then, of course, we have what supplies the charger power itself, main bus A and main bus B, and then, of course, the readout in AC power. We have our instruments. Some of this just has to get unplugged because Apollo 11, yes. Potable water heater, that is pretty self-explanable. The accumulator, though, the accumulator is used as part of the coolant loop. So you have our water quantity, and then we have the accumulator quantity, and this accumulator is just part of the coolant system for the soup loop. Then we have our waste and potable O2 heaters. So we've got our potable O2 heaters and then our waste potable O2 heaters. This is for like, yeah, more waste O2. Yeah, it's just a lot of heaters, to be honest. Our transducers, these are actually used for some data readout in regards to some of the O2 flow, some of the environmental control systems. They have transducers helping with that signal readout, and then the temperature transducer. So here we've got the pressure transducers. These control the pressurization of the cabin and the data readouts. So if you pull the transducers, you lose some of the readouts and the ability to pressurize. We've got System 1 and System 2 in conjunction with the System 1, System 2 down there. And of course, we got our temperature transducer, which helps control the temperature and also gives us the temperature readout. Again, more in depth later as we get to actually tinker with the systems. Then we have our secondary coolant loop. AC for the pumps. We've got our heaters on main A and then our transducer on both buses. And that activates power to secondary coolant loop controls here. And cabin fans. And fans always run on three-phase electrical power. They can run on anything. They can run on 2. They're most efficient at 3. At 2, they run a little slower, and then if you actually pull out, more than 2, like if you pull out 2, it should be that actually the last circuit breaker automatically trips the whole system off. I don't think that that's simulated in reentry. Same thing occurs with the pumps and the soup compressor, but I don't think it's simulated in reentry. I could show you it in NASP, what that would look like. Guidance and navigation, we get the power supplied by AC. That allows us to have some control and some say over the stuff down here. Our guidance and navigation power controls. And then we have the individual components powered by the main buses. We get the IMU, the inertial measurement unit or inertial management unit, depending on, which year you're from. And we, of course, have the heaters, which are color-coded to tell you to never pull those out. And the computer, that one's self-explanatory, and the optics, and that one's also self-explanatory. Intercom system, if you're looking at it, TNR is transceive or transmit and receive if you're not a fan of shortening length. Son of a biscuit. Internet issues. Are you guys experiencing a loss of stream quality? I think I am. Yep. So if you're experiencing a loss of stream quality, just let me know, and then I'll fix up the stream going, because I just got the notification that it disconnected and reconnected. So let me know, and I'll switch networks. It's just a network issue probably. But yeah, most of this here that you're looking at is in relation to the stabilization control system. And you can even see SCS just, except for direct O2, that's obviously not. But our FDI GPI. So FDI is Flight Director Attitude Indicator, which is different than in the Gemini's FDI, which is just Flight Director Indicator, just different nomenclature, different manufacturer, different nomenclature. GPI is our Gimbal Positions Indicator, which is this right here. All of these are actually supposed to be at the bottom in their powered off position. Reentry has them fail open or fail full. They're supposed to be fail 0 instead of fail full, but it doesn't matter too much. We power that off. Oh, actually no, it was powered on already. That's my bad. Reentry has it correct. Fail off. Good. Logic. That's just part of the logic and how it manages everything. BMAGs here. We've got our body-mounted attitude gyro power. These need to be preheated, of course, and they're going to be what manages your readout from the gyros to the backup display. So the IMU has its own display system, and those BMAGs will give you this indication here, as well as the information for the GDC gimbal. So if you have both BMAGs off, the GDC gimbal will not work. But if you had one off and you were on rate 2, for instance, you would only lose your rate readout. You could at any time switch it to rate 1 and get that rate readout back, and vice versa. If both are down, you lose the backup ball because that's actually what supplies the gyro display coupler with the attitude informations. Direct O2, that just feeds direct O2 from the tank into the cabin, pretty self-explanatory. And now we've got our stabilization control system. So we got the thrust vector control on AC1, and then we got the stabilization control system on AC1, AC2. And then here we have the second thrust vector control AC2 tie, and the ECA, which is part of the SCS electronics package. So tie that. We've got our direct ullage that supplies power to this button here. And to be honest, you're never going to use it in reentry. But if you've seen my Apollo 7 tutorials, you'll know what that does. So like, if you want more information, go to my NASP videos where I explain it more in depth. Anything that you're not going to really touch in reentry, I'm just not going to bother to explain. Because reentry is supposed to be beginner-friendly. Why would I explain all the advanced stuff if reentry is supposed to be the beginner-friendly thing? It's just gonna stray people away. Like, they want to fly, they want to fly. Reentry is the quickest way to fly a spacecraft, so why learn something you're never gonna touch if you fly reentry? But yeah, you got your controller and your direct. So this is for your rotational hand controller. Direct power here you can see. And then we've got our AC roll here, BD roll, pitch, and yaw. And that supplies power to these 16 auto RCS select switches. So if you were to have these pulled, for instance, you would lose all power to yaw control from the RCS while on SCS. So keep that in mind. Ordeal, supplied by AC bus 2 and main bus B. That's the orbit rate display, Earth and Lunar. We'll talk about that later. And we've got our control rotational hand controller for the auto system, supplied by main bus A and main bus B, and can be cross-tied AC-DC. So there'll be other circuit breakers for that at some point. Our logic bus that supplies the switch. You've got your logic 3 and 4 and 2 and 3. 2 and 3 can be turned off, but 3 and 4 cannot. Once the circuit breakers are plugged in, they're plugged in. So if you were to pull this, 3 and 4 is out. That's how you would turn it off. It just can't, like, you can only turn off 2 and 3 from here. So, and you got the entire system power. Little floodlight there. Reaction control system here. Your service module heaters. They heat up the 16 service jets. Plug, 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 plug. Now you've got your propellant isolation valves. Propellant. And this is going to supply, you can see, as part of that RCS logic. And we'll talk about why RCS logic is subtied under propellant, under reaction control system, and sort of attached to this propellant isolation. But basically that supplies power to these. Because you can see, look at that, it's not doing anything. I actually have to plug these circuit breakers in order for that to actually work. Now you can see it works. Very good. Command module RCS will supply power to the logic switch here, command module RCS logic. That, in an abort scenario, will auto-pressurize your command module RCS, which is why it is located branched next to the propellant isolation. You can see there's no closing bracket here. The closing bracket actually feeds to here. For both of these systems, and that is because the logic is tied in with the pressurization and these isolation valves for an abort type situation. So, if you haven't seen, actually I haven't even done a video on abort modes in NASP. I'll do a video on abort modes in NASP at some point when we finish this tutorial up, because this will just make a lot more sense. EMS for the entry monitoring system. That is this box right here. We'll talk about it later. Docking probe. That's self-explanatory. Everyone knows what that is. It's a very iconic part of the capsule. Next row is all in relation to the SPS, Service Propulsion System. We have the gauging for that. So the gauging supplied main bus A, main bus B, and both AC buses. That is this indication, this indication, so this indication. So again, gauging is really, really important. You've got your helium valves, which supplies power to these switches here, which you're just gonna always leave on auto, but you can open the helium valve. Helium serves as a fuel pressurizant, so yeah. Then you have your pitch and your yaw gimbals. We'll talk about those later, but those are supplied by battery power. And then you've got your pilot valves. Those pilot valves, like the pilot light on a stove, you turn it on and it goes the tick, 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 tick. But unlike the pilot valve on a stove, this engine does not need to spark. So the pilot valves here are just pre-valves, basically, for your injection valves. No spark needed on those pilot valves, so just pre-valves. And then you've got your emergency detection system, which is what controls some of your abort modes, and also auto abort capability. It's all tied in with part of the booster logic. And then here we've got our entry landing system. That is pretty obvious, parachutes and stuff. And we got our post-landing vent and our flight post-landing bus circuit breaker. So that controls like this vent, the die marker, the beacon light, and then you actually have the post-landing bus itself, which can supply temporary power while you pull off the AC, or main buses, that is. So we'll talk about those two things later during the actual entry mechanics, which, by the way, I haven't done an actual re-entry in the re-entries version of the Apollo capsule in... It's been over 4 years now. So I may die on stream talking about Apollo's re-entry, because last I remember the re-entry in the Apollo capsule was very, very finicky and some stuff would always break. But I was reading over the patch notes and a lot of it did get patched. Back in my day, you had to manually re-enter the spacecraft by hand, which is something that would almost never be done by an astronaut by hand, unless absolutely necessary, because I knew it was like really, really hard to pull off. Yeah, so we'll see. I may die, but that is that's that. Yeah, we're in for a good time then. Absolutely. Let me always refresh my YouTube app. I don't know what it is. It's just the chat. It always disconnects and reconnects. And I want to say it's because I'm logged in two separate places. And YouTube is fighting that. I want to say that's what it is. But I don't have a second screen. Like, I can't go into the Studio app and access the chat from there. Can I? I could try. So go to content, and I go to live. Yeah, it's not even showing up. You cannot access the live stream studio from here. So rip that, but I think it's because it's detecting that I'm logged in two separate places at the same time, so it's always going to bounce to on and off. That's my best guess, anyways. Yeah, this switch turns the IMU on. So at this point, you'll see the no attitude light on the computer, which, hey, by the way, this is supposed to be white. But let's just get our, yeah, this has no light right now, no light emission source, which is driving me nuts. So let's get integral all the way up and see if that, yeah, no emission source on that yet. It's supposed to, but I have a feeling I know which circuit breakers will manage that later. Actually, we're going to sneakily turn this stuff to bright real quick. Alright, system test panel. This just allows you to see different tests, which are listed down here. For the most part, you're not going to use it. There is like one scenario where you would use it, and we'll go through that when we actually get there. But it is in relation with battery charging, but for the most part is not really something you're going to use. This is our optics controls. I'm just setting the switches to their preset configuration. There you go. And now it's all the side panel stuff. Welcome to the postcode modulator telemetry. You've got group 1 and group 2. Those are their own like electrical buses for the telemetry. And then you got the flight bus, main A, main B. So this controls the ties, which allow, let's see what it is, which allow you to plug in main A, main B into this bus here. And you got your pre-modulation power. So you got your primary flight bus and your auxiliary flight bus. Yeah, there's like over 20 buses in the spacecraft, so get used to it. You got your VHF crew station audio, which ties into the flight post-landing bus. And hello, I don't think I clicked both of those, but nice. We got our high gain antenna. Oh, no, we got UDL flight bus. High gain antenna. Yeah, most of this you'll see is just comm related stuff and telemetry. We got our S-band frequency modulated transmitter and our data storage equipment. We got our central timing equipment that powers up counters for these mission timers. You can see now probably mission timer displays are up. Yep. So that's part of our central timing equipment. We got our rendezvous transponder and our signal conditioner. And then again, S-band power amplifier and phase modulated transponder. During Apollo 8 campaign, I had to do it using computer because it wanted to fly by hand, and the computer did just fine. Awesome, awesome, very good. Yeah, back in my days, we didn't have computers for this fancy entry shit. We had to do it by hand, and 70% of the time we were probably dead because it was really hard. Yeah. Yeah, so you see most of this is comms, telecom related, telemetry, BS, and then down here we got our pretty much power sort of BS. We got our fuel cell stuff, our power generation BS is right here. So we've got the pumps for the fuel cells, the bus control, purge valves, radiators, we got cryogenic heaters, and then we have the same for fuel cell 2 and O2. So here's cryogenic heaters for H2, cryogenic heaters for O2, and we've got, again, fuel cell 3, but then we have the quantity amplifier. So this is a little stick in there. It's actually a thermocouple, which can read the quantity of the tank. And then we've got our cryogenic fan motors, which are used to stir up the tank to get more accurate quantity measurements. And then we've got our lighting. Floodlights are now powered. Hallelujah, we can see. Kind of. Now we've got our numerics and integral lighting. And our running lights and EVA and target lights. At this point, we are not going to get the integral lighting because we have not supplied the AC power yet. And we can see that integral lighting does come in through the AC power. We can see lower equipment bay, AC, AC, AC. Yeah, so we need to supply AC bus power for that. That's why we don't get those lights. Yeah, I might add that as a back in my day. Back in my day, my spacecraft had 1.6 thousand switches. What does yours have? 4 and 3 touch screens. Yeah. Electrical power system, yay! All right, so we get our group plugs, group 1, group 2. So this you notice Group 1, Group 2, Group 3, Group 4, Group 5. Coincidence that some of this stuff has Group 1, Group 2, Group 3, Group 4, Group 5 for telecom, for power systems. No. This is the EPS ties for the Group 1, Group 2, Group 3, Group 4, Group 5 telecom shit. So that's where that comes in. We got our utility power and our electrical power system battery bus. Again, so many different buses. There's like, oh my god. The more I look, actually, now that I realize that each group is its own bus, there is probably over 30 electrical buses in this spacecraft. The more I count, I always come up with more buses every time I count. I think last time I was teaching Rebel, and we had determined it was like 25 or 26. Yeah, no, add another 5 to that, plus the EPS bat relay bus, like 30 electrical buses. Every time I count, it's just always more and more and more and more and more. Timers, that supplies it for this 2 digital event timers. Excuse me, should probably take that water now. Every time I get in the CSM, I'm like, how many buses do we have? Let's count. And now we're up to 30. Well, we ended at like 25, 26. Now we're up to 30, 31. Yeah. Just don't look at it for too long, right? The longer you look at it, the worse it gets. SPS line heaters, here you go. That is pretty obvious. It heats up the spot. Yes. I remember I was always wondering, like, what the hell are the O2 vacuum ignition pumps? Actually, I think that's a typo. I'm very certain it's supposed to say ion pumps. Did you Google how many buses it is, and it came out to 45 in Google? Is that what you're telling me? That it's 45 different buses? Oh, but yeah, so the O2 vacuum ion pumps, the cryo tank gets its insulation from a vacuum pump. I was like, what the hell does this do? But I should have realized, because my lab equipment is the same way. Like, you have a, well, in my lab equipment, you have a liquid helium layer, and then you have a scroll pump, which creates a vacuum, and then out of that you got your liquid helium, then you have your liquid nitrogen. Thank you, couldn't remember the atom. Liquid nitrogen, and then you have a pump which pulls a vacuum from the outside of the tank, and this insulates it. So not only do you have insulation in the form of liquid nitrogen, but you also have insulation in the form of there's no molecules to communicate heat transfer, and that's what those do. So I finally got the answer to that. Shout out to the NASP. Shout out to the NASP people. Shout out to the NASP people. Hey, Kurgert. Funny seeing you here. Yeah. We're flying in reentry. And, you know, normally I fly NASP, but a lot of beginner people buy reentry because it has, like, the Gemini and Mercury. And they also want to learn Apollo in reentry because it's more simplified before they hop over to NASP. They're working on. Disconnected again. Are you guys getting data? Yep. Small frame drop. Heading to bed, that's right. Don't worry, Kurgert. I will be going back home after I graduate, so you'll actually be able to join some of the streams. So, cheers. You'll be able to join at some point because I'll be graduating soon and going back home. So, woohoo! Yeah. So our schedules will be more aligned. I know Madison isn't usually available until later on. U.S. time, so it really, like, Madison's schedule somehow always lines up with the old European schedule, and I don't know how. This Madison's up late, I guess. So, yeah, I had no problems, like, with Madison being able to join my streams while I was in Europe, but as soon as I came to the US, Madison was like, oh, I can't join, like, some of them because I'm busy. So, I don't know. It's just since I got a bulk of my popularity while I was streaming in at home in Europe, that's where, like, most everyone's schedules line up, right? So you'll be able to join again. So have a good night, and thank you, because we are going to be clicking buttons and switches for a long, long time. I have bad insomnia, that's why I'm always up. You know what? The one-time insomnia works to your benefit, right? Speaking of benefit, look at this. Pyro, sequence A, sequence B. We'll talk about that later. But hey, now the pyro batteries are tied, and we can actually get a readout from the pyro batteries. Speaking of which, now that we have telemetry powered up, we get our ammeter power as well. Kind of crazy how that works. Pretty cool, pretty cool. Yeah, if these are unplugged, we shouldn't be able to get the voltimeter readout from the pyro batteries. Ooh, yikes. Okay, definitely gonna have to send that to Petrie, because that's not how that works. Those are supposed to actually completely isolate the pyro batteries. So, yeah. I'll have to message Petrie about that later, but it's fine. It's like a really small, like, again, beginner level, so it really doesn't matter at the end of the day. And here, this is mostly where we can tie our batteries to different buses. We can tie battery A to the power entry post-landing bus. We have a power entry bus now. Okay. Sure. Battery B, battery C, we can tie those, and then we can also tie battery C to the charger on EDS2. And you notice we leave these out. Battery C is an independent isolated battery. It would normally be connected when you turned either of these two switches on, because you can see AC and BC batteries. C occurs on both switches, but it won't unless you have either of these two circuit breakers plugged in. Then that switch goes through to wherever you select it to. For instance, if we tied bat C to bat bus A, and we turned on the AC switch, both A and C batteries would tie, but if we pull the circuit breaker, only battery A would tie that bus. So, main bus A is tied by battery bus A. Main bus B, we can power through battery bus B, but also keep in mind, we also can tie the fuel cell, the 3 fuel cell buses, to the main buses. So these are just the circuit breakers. For the power, you can trip off the fuel cell here. So these are like their own circuit breakers, kind of. So that's why you don't see fuel cell 1, fuel cell 2, fuel cell 3 buses as circuit breakers here for main A, main B. Our flight post-landing bus would take main A and main B and tie it to the flight post-landing bus. And then we have our inverter power, which, hey, now that we have power to our inverters, we're going to get AC. So here we go. Boop, there you go. We got it. Nice. Now it's looking lively in here. Instrumentation, power and control. I'm not sure exactly which systems these power, because we do have a lot of our gauges already powered, but it's very obviously instrumentation. We got our S4B, lunar module separation, pyro bus ties. Because once you're separated, why would you power the system? Everything else you can have powered, because it's kind of like you use it a lot, but this is like one time only. You're never even going to think about using it ever again, so you just pull it from the ties. Yeah, saves a little bit of power, right? Here's our suit flow control. All these go to full flow. When there's no one suited, all three go to full flow. When there's one person suited and two persons in the cabin, you'd have like one on suit and two in cabin or whatever you need. It basically just controls the flow of oxygen through both the suit loop and the cabin. Here's our primary cabin temp selector and our secondary cabin temp selector. And to be honest, I don't think the primary temp selector, as far as I know, is this right here. And the secondary selector is over here. NASP only has one of these, so I'm not confident in the fact that there's two here. But this could be a different version of the capsule as well. There's multiple versions of the capsule. So here's our drinking water supply, which is coming off now. Sadly, I can't find the exact number of electrical buses, but I'm sure the NASP guys know. Yes, I'm sure they do. Mission timer, that's pretty self-explanatory. Notice how it is counting right now. Don't worry about that. It does get the timer signal reset later. All right. Woo! We are 45 minutes into this. All right. 45 damn minutes into this. Nope, 57 minutes into this. And we haven't even gotten past the first checklist. Oh, I told you guys. We're in for the long haul. Didn't I tell you? And what just happened when I said that? What happened? Exactly what just happened. This might be based on 11. Yeah, so if it is based on 11, I don't think the primary controller is there. I can pull up NAF just to make sure I'm not being an asshole and wrong about it, but I'm 99% sure the primary controller is not located there. I'm 99% sure that actually, not even, I know where the primary temperature controller is. It is not, this is the auto temperature controller. Primary temperature controller is actually this right here. This valve, this is the primary cabin temperature controller. This is the secondary cabin temperature controller. That's what it was. I distinctly remember. Because I was talking about how insane the graphic was on the picture of that valve in 2D. Like, it looked 3D in 2D because the picture was such a high quality. I remember that. Oh, yeah. The NAS people, way more knowledgeable than I am. I would say that I'm a lot better at explaining things. They're a lot better at having the knowledge. So, yeah, I will, explain things from a beginner standpoint, but they could talk your ear off and go on for days. Anyways, we're at the cabin pressure relief valves. What these do is sort of the cabin temperature, or cabin pressure that is, needs to be psi higher than the outside at all times to maintain structural rigidity. So as you're going up, you're at 16 psi because the atmospheric pressure is 12 psi. Normally, standard 1 atm, 12 psi kind of thing. So as you're going up, the outside pressure is decreasing, which means that if you didn't have a sort of valve system which would bleed off the pressure, the thing would explode. Like if you put soda in a cup and you close a lid and it doesn't have a little hole in it, like it could be via the straw hole or something. Like, it's a completely sealed lid, not even a micro hole in it. You seal it, and you shake it. The cap bulges and bulges and then explodes off. And yes, our cafeteria does not have holes in our lids, and I love doing that. I take the cup outside. I'm not a heathen. I don't have a mess to clean up, but yeah, that's essentially the same thing. So you need to be able to tell this system to manually dump pressure if required, or to have that sort of butterfly valve going where when the outside or when the inside is greater than 5 psi differential, it overcomes spring tension, opens the valve, and you dump the pressure. And when the pressure is equal to or less than the 5 psi difference, it does not overcome the spring tension and closes. So, yeah, pretty basic systems. And then you can just turn the whole system off with the close feature. Normal is normal operation, allow you to pressurize, allow you to like depressurize, whatever, normal operation. Close shuts it off, manually dumps the pressure if you notice that during boost you can't get the pressure to relieve. So that's basically what this does, sort of two-way system. And of course, two of them for redundancy. So this is what they mean when they say the cabin valves remain sealed after the total pressure reads 0 and you get the 5 psi. Cabin valves remain sealed. That's what these guys do. Yeah. Glycol reservoir. This is just a reservoir of coolant. It's pretty self-explanatory. Caution warning light. And it was from like Apollo 7 through 9 testing for the SPS. Yeah. I know there's also some switches here for like Apollo 7 that are supposed to be here. And believe it or not, I think this is labeled in the Apollo 11 cockpit, just the switches have been removed. But they're called something weird, like SPS pilot valve switches, I think is what was here, and they got removed at some point. But yeah. Here, these are the pressure regulators. Again, we'll talk about those more. Waste servicing system and potable servicing system. This is just where you can control your inlets to the potable and waste tanks, where you can dump it, where you can, set things to auto and stuff like that. It's the water panel. We've got our PLVC. And to be entirely honest, I forgot what this stands for. But it never leaves normal, so just like, you shouldn't have to touch it, but there we go. Again, a little disconnect and reconnect. If this keeps happening, I'll probably stop after this checklist and then resume at some later point. I also have to get food at some point, so. Here we got our demand regulator for the suit pressures and stuff. This controls the suit like compressor to change the pressure. The pressure should always be, as you can see, slightly higher than the cabin, and that's completely normal. This is the suit circuit return. It allows you to basically like turn off the suit loop. You can either have the suit loop run through the cabin loop or have it isolated. So suit circuit return valve, you can push to close, pull to open. When you pull to open, it runs through the cabin. When you push to close, suit loop becomes isolated from the cabin loop. Good for EVA. Then you have your coolant attenuation control panel hidden behind this door. You got your suit heat exchanger, which you should always flow. And then you've got your heat exchange secondary set to flow. You got your evaporator controls, both go to auto. And then your water accumulator, which again was like the coolant in the suit loop. As we talked about, accumulator for the suit loop coolant. And there we go. We are at the end of the first checklist. Huzzah! How long did that take us? 1 hour and 5 minutes. Okay. So 1 hour and 5 minutes. You know what? I don't even know if I have chat replay saved, so I'm just gonna make a note on my notepad that hello, we are 1 hour and 5 minutes in. Streamlabs time, and this is like finished with backup crew ingress. And I could basically, and I can also title this as like a very broad overview of systems, and then more the nitty gritty when we get in. It's, finally, we're here. Moving on down the line, activation. So activation is kind of an easy procedure here. This is what would normally be normally done when the backup crew ingresses. These would normally be open like this. Everything else would be closed, but these would be open, and you just sort of plug these two in right when you get in, and you flip caution and warning to 1, and you get the caution and warning lights, which should say nothing except for suit compressor and possibly cryo pressure. But there is a sort of ground system which should prevent the pressure from dropping, even though our heaters are off. And at some point we switch to the heaters. That ground system's removed. And you may also get the O2 flow high if this door is closed. At this point, the door is actually supposed to be open. So we can actually toggle hatch and have that open, because it is supposed to be open. And yeah, so now you do the computer stuff. So you would plug in, normally be unplugged at this time, and you plug in the computer circuit breakers, and then the computer would come up. And then you would do your verb 37, enter, 00, enter, and then the computer would take like 10 minutes to load at this point. And then you would do your Disky lamp conditional, or your Disky conditional lamp test, verb 35, enter. This is supposed to make the master alarm go off, so you push the master alarm, verify the computer light comes on, verify all this comes up, and then as soon as this test is done, after like another 15 or so seconds, computer light turns off. Then you do verb 37, enter, 00 again to clear the display. And then you're going to check if the mission elapsed timer is working, depending on the mission. Some missions don't do it, some do. But you can call that with verb 16, noun 65, enter. And this is a sort of computer elapsed time. And don't worry, this will get reset to 0 on liftoff. But you're just making sure that the computer's internal timing logic works. Again, verb 37, enter, 00, enter. You would power up your IMU, wait for the no attitude light to come out, and then you would supply power to FDAI 1, like that, with everything still off. Oh, and hey, by the way, only these first 2 needles should actually power on with 1, and when you switch it to 2, only these second 2 needles here and here should come on, and with both you would get all 4. So that's just a little thing to point out. So at this point, this gauge here and this gauge here should be non-func, and this one should be working. So yeah, just it's really nitpicky. Like reentry is supposed to be for beginners, it doesn't really matter, but just something if you fly in NASP you'll notice. And then verb 37, enter, 0, 1. And this will align the IMU to the launch refs mat. And as soon as it is in align, or as soon as it's done aligning, the no attitude, or also in align light, depending on which version of the capsule it is, will go off, and then program 2 will automatically start. And what program 2 does is it gyro compasses the IMU so that it's not subject to drift as a result of Earth's rotation. So you'll see it went from course align to pulse align. Pulse align is over. The no attitude light should turn off very shortly, and we'll get program 2. There you go. Program 2, the IMU is now gyro compassing with Earth's rotation. Very good. And at this point, you can turn off the FDAI. And that is the activation steps complete. Any questions? Any questions? Oh boy, more things to work on. Yeah, it doesn't need to be done. This is nitpicky. I just have to point it out. Because we're an education channel. So something has a discrepancy from real life, I must point it out, you know? So that's just kind of what has to happen. Not trying to be an asshole. It's being like, this is not how it's supposed to be. It's just, if there's a discrepancy, we all know reentry is a beginner gamified sim. For beginners, by beginners, for beginners, is not that big of a deal. It's just, I gotta point it out when there is that discrepancy. So, activation is done, and I'm genuinely starving. So I think let's take a look at the next few checklists. I think what we're going to do is we're going to take a break. Actually, no. You know what? Not yet. I'm going to order food, and then when the food arrives, we're going to take a break. I will maximize your time because I know what Rebel's really looking for is the flying bit. The bit where we actually fly, because that's the part that he's having the most trouble with. He already did all of the cold and dark stuff. He needs to get to the flying part. And so I'm working as fast as possible. I don't want to waste anyone's time. So let's order food and then continue on until the food comes. Then we'll take a break. I might end the stream just because the stream is getting really long now. And then we'll start up another one after I finish eating and I take a break. And we'll go from there. And I'll see if I can't fix that network issue as well. I just saw another 700 dropped frames, so yeah. So just give me 2 seconds to order a little bit of food. The food is going to get here relatively quickly, I would imagine, so it's not like we'll be saving much time. But it is still time saved nevertheless. Oh yeah, I wasn't even planning on streaming tonight, which is why I didn't make the announcement, because I was gonna go out to eat, but then they weren't, like, running the stuff, the transportation services. I'm not used to, like, living in a country where there's Thanksgiving, so yeah, I'm not used to it, so it's like everything closed, so. Yeah, I was gonna some really good food, but I was like, damn, they're closed. So it's gotta be fast food now, unfortunately. Yeah, whereas like in Europe, this is normal, but like only on Sunday. So like there's not very many national holidays aside from like your typical religious ones. So. All right, let's get into it. Starting with our caution and warning checkout. So again, caution and warning system, as we've already pretty much pointed out, it's what controls the lighting and the master alarm here. Certain cues for trouble lights. So to test that out, we're just going to hold lamp test and verify all this is good. Verify that light is on, but that light is off. And then if we switch to boost, both lights should be off. And if we go to lamp test 2, it should be left light off, right light on. And if we go to boost, it should be that the right light maintains its on. Very good. Now if we go to command module, we should get to command module RCS lights. Very good. That's it. That's the whole test. Very easy. And then you flip this to acknowledge, which is supposed to turn off all of the lights. However, it is not. So yeah, it's not that big of a deal, but it's supposed to turn off all the lights. Yeah. I thought maybe it was just the lights in re-entry stay on, but like that you don't get new ones. No. It's just that switch position is just fully not implemented. The castles, there's a lot of castles, but not as much as you would think. Not as much as you would think. All right, entry monitoring system. So a deep dive into this. This system is a backup to your flight computer. This allows you to basically control cutoff via the stabilization control system for your engine. It also allows you to look at your RSI, or your, I think this is called the roll scale indicator. Basically, however much you rolled by. So as you roll in re-entry, this needle moves, and then it has two lights. It tells you if you need to enter lift vector up or lift vector down. If you're Earth orbit only, you're usually going to want to enter lift vector down, and then if you're lunar orbit entry, you usually want to enter lift vector up just because of the difference in speed. It also gives you so it gives you your G-force at a certain velocity. So you can trend. Like you can say like, okay, we're having too much G's, we're having not enough G's, whatever. And then you can also read out your range to go. So that's this system and how it works. This is supposed to have a cover. It does not, but this is the ground test accelerometer, not Grand Theft Auto. Ground test accelerometer. You flip it on, and you flip this to delta V, and you flip this to normal. And unfortunately, this switch... Oh, it does actually do something. Hello. However, it does not the right thing. This is supposed to stop this from counting at all. And then you would monitor this for 10 seconds and make sure that... that's weird. Make sure that this changes by less than 0.1 per second. That is so weird. I have no idea what is even going on with that. It stopped at 499, which doesn't even make any sense because gravity is 9.8 feet per second, or is 9.8, 32 feet per second, or 9.8 meters per second. So this number doesn't even make any sense for it to stop on, but whatever. We'll ignore it. Oh, hey. It also is not resetting when it's supposed to. But yeah. Oh, hello. The EMS is... there we go. You're supposed to be able to set the delta V irregardless of the switch position for this, but interesting. Again, EMS is... wow, EMS is broken. You're gonna punch in 1,586.8. So 1,580. Oops. I'm used to being able to right click and NASP. 86.8. And then you set it to DV test, and you see the SPS thrust light on, which is far too bright. Classic reentry thing where the text becomes illegible due to brightness. And it should stop at actually under 0. You may think it stops at 0. It stops at under 0 due to off. However, thrust trail off is not modeled. So it is actually not going to stop at like -20 or -19 point whatever. It stops instantly pretty much. So thrust trail off not modeled. But again, beginner level, so that this complex stuff doesn't need to be modeled, although the fact that this is egregiously broken is a problem. You can't even excuse that as a beginner thing. That's just a problem. So yeah, that's how you test that, and then you go through EMS test 1, flip it to normal, and you're gonna wait a little bit, and then you're gonna basically move the scribe here, the scroll, sorry, so that the test pattern is in between these sort of two notches here, and you're superimposing the scribe onto the test pattern. You go to test 2, and after 10 seconds, you should get one of the lift vector lights. I think it's down, lift vector. No, sorry, it's 0.05G light first. So get the 0.05G light after 10 seconds. Hello? It says here, system test. Test 1, normal, no lights, set scroll. Test 2, 0.05G light. Ground test accelerometer? Yeah, ground test accelerometer. Okay, so this is supposed to work irregardless of the GTA, actually. But that's fine. We'll have to wait for that test to run up again. That's my fault. The GTA switch is supposed to remain on for these tests. But this should still work irregardless of the GTA test position. Coming to test 3. You can see here, test 3, you'll get the lift vector down light, and we also need to set our range to go to 58. There's that lift vector downlight. And now go to test 4. And the scribe should trace the pattern. It's actually not going to trace perfectly. It's going to trace in between these two things. But that's not that big of an issue. And when you click to test 5, scribe should trace vertically up to about this point here. And then when you turn off, it'll come full scale high. So, yep, we see that lift vector up light. We see the tribe has traced vertically. Look at that. We can see it tracing. And it's going to stop. Yep. And range set. And it should go all the way back up to the top. Now we take this switch off. We take the GTA switch off. And we go all the way left to off. You never enter EMS test backwards. So you never go like, oh, 5, 4, 3, 2, 1. Nope, don't do that. If you're at this point, you have to suck it up and go all the way around the left way. Any questions with the EMS? And I do see chat disconnect, reconnect, so just a simple test message. See if that's getting out. Good, that's getting out. Any questions with the entry monitoring system? And it doesn't look like there are any tests or anything. Can it be less broken? I mean, it's not that it's broken, it's just that this is one of the first systems implemented. So, I mean, yes, it's broken, but it's one of the first systems implemented. He's just got to get it back around to like when he does the flushing out of all the systems again. He's done it in Mercury and he's done it in Gemini. Now he needs to be at the point where he does the flushing out of everything in Apollo. And this was one of like the first coded things, was like not coded, right? Obviously, it's like the first thing. It's like one of the first things with the Apollo capsule. So when he gets around to polishing everything like he did with Mercury and Gemini, it will be done with the EMS. I can assure you that. Like the nitpicky stuff will be fixed. Onto EMS, onto glycol loop checks. So to test this, you're going to come over here and you should see the glycol to radiators secondary. Set that to norm. And once that's on normal, you're going to come over here and you're going to set indicators to secondary. And you can see all your needles change, and you'll power up the secondary coolant loop pump. And you can see with that, radiator stuff has changed, the glycol pump discharge pressure has changed, accumulator is dropping slightly and will stabilize out. Most importantly, you want to verify that discharge pressure. And by the way, the temperature disconnected again. And reconnected. Okay, we're on. Hopefully he fixes the text washing out. Yes, I hope so too. That happens in every capsule. But yeah, as I was saying, basically, like, these gauges are not going to change that expeditiously. Like, look at that. That's never going to happen. This pump needs to run down. By the way, it will run down to 0. It's not going to stay up like that. It will stay slightly above 0 because the gauge is powered, but not this dramatically above 0. But yeah, you can see it's expeditiously doing it, and the temperature just fell instantaneously. Again, this is mechanical equipment. It needs to drop at some point. So, like, this is excusable for entry because it allows you to see, like, how a system affects the readouts. But it's not how it would have happened in real life. It takes much longer in real life for these changes to take effect. But yeah, then you test it on the secondary position. Once that's good, turn it off and go back to primary. Once you're on primary, you can bypass that secondary glycol to radiator and then just test that. We can see, just test glycol pump 2 tied to AC bus 1, and we get the readout. Very good. And now we'll test glycol pump 1 on that AC1 readout. and we get the indicators. Good. And forever it will stay. And now we need the direct O2 valve adjusted for 0.4 plus or minus 0.1. So just a little bit over halfway. So we're at 0.3, 0.4 right now. And we can get it probably just one more click. 0.2, 0.3, 0.4. There we go. That's where it's supposed to be. And believe it or not, this implementation of the direct O2 is more realistic than what's in NASP. Because NASP has it plumbed in wrong at the moment, because this specific valve was also one of the very first things that they coded, so it is slightly broken. So it behaves differently, but the rest of the systems have been flushed out. This is the last thing that needs to get repiped in NASP, and it will be good. So Reentry's got a leg up on NASP in this regard, because this is exactly how it would operate in real life. Bravo. Moving on, I think we have time for our standby inverter check. So as you know, the inverters create AC power. One small thing. This switch is not supposed to untie the inverters. It's only supposed to control the sensing circuitry. So turning this off would still have the bus powered. It would just prevent the master alarm from going off as a result of changing the inverters around. But yeah, here, tie this to main bus B, and then turn the sensing circuitry off. Turn off inverter 2 from bus 2, tie inverter 3 to bus 2, reset, and verify stable volts. Again, power off. Sensing circuitry off, untie inverter 3 from AC bus 2, tie inverter 2 to AC bus 2, reset, verify all buses and 3 phases show good, which just is a little bit, that's perfect. That is where it's supposed to be. Yep. And now you can untie main bus B from the third inverter, turning it off. And that's the inverter check. Pretty simple. Inverters create AC power. Very important. Now we're up to the fuel cell radiator and float bag check. So for this, you're going to come down here and ensure that all your radiator circuit breakers for your fuel cells are closed. You're going to come up here, and you're just going to make sure the talkbacks are gray. Normal, 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 just to be sure that this actual position and talkbacks are in alignment. And once those are gray, you're able to just pull your radiator circuit breakers. So pull. This one circuit breaker tends to be a little bit of a headache. There we go. Pull, pull, pull. And there you go. All that's done. And here, it's actually a little bit dark down there, so let's get some floodlights going. So yeah, your react circuit breakers and your radiator circuit breakers are always going to be unplugged so that you don't accidentally do something which would be catastrophic for the fuel cells. What cool stuff NASP has and is coming. Yes, yes, I can't wait till you join in NASP. You should record videos about it. Oh, I would watch them. I'm not even gonna lie to you. I would watch every single one of them. Alright, moving on. Float bag check. For this, off, off, off. Circuit breakers here. Close, close, close. Vent, vent, vent. Houston gives you like, oh, hey, the float bags check is good. Open, open, open. The easiest test in the entire capsule, and also very satisfying, because it's literally just bam, bam, bam. Or it's sequence backwards here. It's bam, 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 bam. Very satisfying, but yeah, it may seem silly to you, but this is one of those that, like, Skip Chauvin, the space vehicle test conductor, would be like, hey, you're good on the float bags, you can pull the circuit breakers now. So, if you're wondering why it's like, I turn these off, I plug the circuit breakers in, I turn it to vent, and then I immediately unplug it, is not that you immediately do it, as a Skip Chauvin has to tell you to undo it. We don't have a space vehicle test conductor loop or a mission control loop. Normally, mission control loop you do have in multiplayer, but again, no space vehicle test conductor, so no one to tell you when to pull those circuit breakers. So you just do them right away, like it's part of the checklist. Yeah. Alright, moving on. Lower hand equipment bay, ECS valves. So verify glycol to radiator secondary is bypassed. We already did that as part of the secondary test. Primary accumulator fill valve should be off. Primary glycol accumulator valve should be open. Very good. Y strut retract, that is part of the seating configuration, so that you can open this panel here. Because yeah, you can see, like, hey, there's the strut that very clearly would prevent you from closing the door. So you open this up, and you're going to verify that your suit heat exchanger is on flow, and then warning, suit flow relief valve must remain off through flight or swallowing of CO2 odor absorber filters may result. You see the same thing. Suit flow relief must remain off in flight. So that's this guy here. Suit flow relief is off. Glycol evap in temperature should be minimum. Good. Evap H2O controls. 2 of them should be auto control. Very good. The H2O accumulator should be on remote, which is also auto control. There's off, manual control, or local, as you would call it. In the system, or in the engineering gig, we call this local, like in terms of process engineering, and then remote would send it up to the control room, which in our case is panel 2. So both of these to remote. Once you're done, you can close coolant control attenuation panel, mount YY strut, and open the CO2 absorber cartridge panel. From here, just going to make sure that the CO2 gas diverter valves are in that center position, meaning that both of them are open. No mic. Okay. I can still watch and like make sure you're doing everything right. Well, but it would be much more enjoyable with a mic, obviously, but I understand. Microphones can be a little pricey. The one I have, you may notice the one I had in Europe sounded much, much nicer than the one I currently use. The one that I have in my college room is a little like shitty, like $25, $50 microphone, little desk mic thing. And it's good enough. So it's like, it's what you have. I used to use a PlayStation Eye camera as a microphone, so ooh, throwback to those days. Yikes. But yeah, if you verify those are open, you can close the CO2 absorber panel. Now you make sure both main pressure regulators are open. Make sure that your regulator selector, your H2O glycol tank regulator selector is both. Mix water with glycol. And then your relief is set to both. Your emergency cabin repress should be off, and your main cabin repress should be off. So that's good. Under the water tank control panel here, you're going to verify waste tank servicing is closed. Your potable tank inlet is closed. Your waste tank inlet is on auto, and your pressure relief is on 2. Basically, this is, not actually, like, this is, you can dump the tanks, or this will automatically be like a pilot-operated relief valve. Like, it automatically will blow down the tank when there's too much pressure. It'll automatically blow down the water tank for you. So that's what we're looking for. Forward hatch now. Ensure that the equalization valve is closed. Ensure that the tunnel vent valve is set to... Here we go. Set to lunar module, command module, delta pressure. This is supposed to read 0, since the inside cabin and outside atmosphere have 0 differential, and this only reads like the sensor at the front of the hatch. But it reads 4 because both of these are, and NASP has the same thing where it's like simulated with like a kind of a like tank kind of simulation for this readout. So yeah, this is normal. It's supposed to say 0, but it'll say 4, and that's completely normal. So yep, that's that. Suit flow controls, all 3 are at full flow. And then, yep, cold, max cool, and drink supply valve off. So that completes our lower equipment bay. Left-hand equipment bay, ECS valve check. Any questions so far? Nope, okay. Let's see, how big is the right-hand panel? Right-hand panel, not that bad. I could probably get it done before Wood is here. So panel 225. Everything is closed except for the high gain antenna. Which, yep, we see everything is closed except the high gain antenna. Good. 226, radiators, fuel cells, and COAS tunnel lighting B should be open. COAS tunnel lighting B open, and the rest is where it needs to be. Main release and the O2 vacuum ion pumps both open. We know that, and everything else closed. Yep, whole thing down is closed. These 2 open. Good. Panel 230 is a skip. It's all the science equipment. It's also skipped in NASP. Here we go. Battery bus A-B to pyro bus open. Cert battery C to bat bus A and B open. So exactly as we have the panel configured now, and everything else closed. Overboard drain valve should be off. Oh, by the way, never, ever, ever have these 2 closed while the sequences are open. It will result in a loss of power on the pyro batteries, which is why these 2 are in orange, because they have a special condition. Overboard drain off, battery vent should be closed, and waste storage vent to vent. And a repress O2 on panel 601, which is up here, should be closed. And that completes lower equipment bay checks for the right-hand side. Now it's the timer panel and the system tests. Any questions again so far? If not, then we're going to take a break here. We're going to end the stream. And I totally forgot to write down the timestamps. But I'll say that at like 1 hour 47 minutes, we got to LEB and timer panel. Specifically up to LEB and timer panel. And everything else in between is all systems checks. So, is break time. I'll make a new stream since this one's getting long. So yeah, I'll see you guys soon. I gotta eat. It's probably gonna be like, I don't know, an hour or so. So yeah. Thank you guys for stopping by. And as always, please, 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 if you haven't, subscribe. If I get 500 and we're at 374 or 375, one of the two. If I get to 500, I can put out like the ability to like join, and the money can fund better recording equipment and also my Apollo spacecraft, which I will be building in real life, like a capsule, the simulator. So yeah, immediately it would go to better recording equipment because I don't want to make the commitment to building the capsule simulator, but it's like a 90% chance that we will be building a capsule simulator for Apollo. And so please, if you subscribe, we can get to the point then where I can crowdsource the funding for better equipment and also building the simulator in real life. So yeah, please subscribe if you haven't. Much appreciated. And I'll see you guys after I've eaten, and we'll finish off these pre-flight tests. Thank you.